Hello friends, today we will find the refractive index of this glass slab. For that we have taken this glass slab here, right? And we have to take three pins. One is green, yellow and red. This we have taken three pins. This is green and this is red pin. This is green pin and this one is yellow pin. We put it in this side to represent the incident ray, right? And we put three pins on this side such that all the pins are in a straight line. If we see through this refractive surface, this one, let us see through this refractive surface and find the exact position of the pins of the refracted ray. First you see, the first one is green pin. Let us put the green pin at this position. After that it is red pin, that is red pin, and after that it is yellow pin. We have put all the three pins here. Now if you see through this slab, you see here that all the six pins are in a straight line. You see, if you see clearly through this refracting surface, you will see that all the pins are in a, let us see, let us move the camera. You see very clearly that all the six pins appears to be in a straight line, right? Can you see? If you see it very clearly that all the six pins are in a straight line. If you see through this reflecting surface, all the pins are in a straight line, right? Now, here you see, this is our experimental. This is our glass slab. These three pins represent the incident ray and these three pins represent the refracted emergence ray, and the refracted ray is here. Just fine. Here you see, here we have drawn the glass slab. This is one normal, this is another normal, right? And you see this is our incident ray. This is our angle of incidence. This is I1 and this is R1. R1 is equal to R1. This angle will be equal because these are normal and these are alternate angles. And here see, this is the angle of emergence and this angle will be same. He will represent it by I2. Right? This is I2. Now we will find the refractive index of this glass. How? You see here, if you remove these pins and if you measure the angle of incidence with the help of protractor, let us measure the angle of incidence with the help of protractor. What you are finding, you see here, we are finding the angle of incidence here. Here you see, the angle of incidence is exactly 30 degree, right? Therefore, we are writing here it is 30 degree. And angle of reflection, if we want to measure, let us measure the angle of refraction. Angle of refraction is see, this is our angle of refraction, and if you see it very clearly, you will see that the angle of refraction is angle of refraction is 15 degree, right? Angle of refraction is 15 degree, therefore this angle is 15 degree, right? Now if you want to find the refractive index of this glass, we know that refractive index mu is equal to sin I by sin R1, sin I1 by sin R1, sin R1. Now the angle of incidence is 30 degree, therefore we can write sin 30 degree, and R1 is 15 degree, therefore sin 15 degree. Now the value of sin 30 is 0.5 or half, and if you find the value of sin 15 degree, it is 0.258. 0.258. Now if you divide 0.5 with 0.258, we are getting nearly. If we divide this one, 0.5 by 0.258, it is nearly equivalent to 1.9. Okay, therefore we are getting that the refractive index of this glass slab is nearly 1.9, because we know that mu is equal to sin I1 by sin R1, and sin I1 is 30 degree, sin R1 is 15 degree, and what is the value? 0.5 by 0.258, the value of sin 15, and therefore we are getting the value as nearly equal to 1.9. Therefore we can say the refractive index of this glass slab is 1.9, nearly, right? Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.